Unit 4 Chemistry, Chapter 16, Part 3, the hydrolysis of some specific food molecules then. So, as discussed, we can hydrolyze proteins into their composite amino acids. We can also hydrolyze carbohydrates then back into their monosaccharides. Okay? So, for instance, in the human body, we can eat starch and we can break it down into glucose. It's got two polymers, remember, amylose, which is your unbranched one, looks kind of like this, it's in a spiral, and then a myelopectin, which has got lots and lots and lots of branches on it. The branched myelopectin is very useful because it can be broken down a lot more quickly. Okay? When we want to break it down, we can only break it down from an end. So for starch, we can only break it down from here. Come along. But for myelopectin, we could break it down here, and here, and here, and here, and here, and here, and you get the picture. This being broken down more quickly is what you'll find more in refined starches, and that has a higher glycemic index. So the glycemic index ranks carbohydrates on how they affect your sugar over a 2-hour period. It's compared to glucose. So glucose is our reference value, and we give it a glycemic index of 100. That doesn't mean it's the maximum. Okay? There are things that can be higher than that. Anything with a high GI breaks down quickly, releases the glucose into your blood very quickly, and therefore it might even give you a bit of a kind of sugar rush and then a crash. Things which are lower are going to release their energy much more slowly. Okay? So you can see it rises, but not as high, but it stays higher past that 2-hour mark. Okay? Here are some examples of some substances and their GIs. Okay? So white rice, you'll see, has got a much lower GI than brown rice. Okay? Wheat bread has got a higher GI there. Okay? You can see that things like jelly beans have also got very, very high GI values to them. Fats and oils can also be metabolized, and they make glycerol and fatty acid when they do. They can also undergo a process called oxidative rancidity. If you ever heard of someone saying, oh, that's rancid, particularly in reference to butter sometimes, what they're basically saying is that the fats and oils have reacted with oxygen in the air to make ketones and aldehydes. And that is a process which is driven by free radicals. Okay? Now, free radicals sound really exciting. It sounds to me like people being protesting and going, yeah, we're free radicals, man. It's nowhere near that exciting. It's something with an unpaired electron in it, which is denoted by a dot. So here's a methyl group with a free radical. Here's an OH group with a free radical. And we make them when we break a bond, normally in an unsaturated fatty acid, quite often due to sunlight being present. So if you leave something like seafood out, particularly in a sunny place, that's going to happen really quickly. Don't do that to your seafood. You are then not going to want to eat it. Okay? So there's a few steps in our auto-oxidation. First, we have initiation. So we have our sunlight, which makes a free radical because we're breaking something apart. Then we have propagation. Our free radical causes a chain reaction. Okay? So our fatty acid reacts with oxygen to make a peroxide. That can then react with another fatty acid to form a hydroperoxide. And then our hydroperoxide is going to break up to make ketones and aldehydes of different lengths. That can keep going for a long time, the propagation. Eventually we'll get to termination, when two radicals combine, and they can therefore not react anymore. So now we're back to paired electrons. Okay? So we can start with our unsaturated lipid, okay? And then we can make down here, we'll see that we start to make our ketones and our aldehydes due to that in our propagation process. Okay? Now, free radicals are very important. The free radicals can be counteracted by antioxidants. Okay? So an antioxidant, as the name would imply, is something that acts to stop oxidation occurring. Oxidation makes free radicals, which set off a chain reaction. Seen in oxidative rancidity, but also seen in other processes, natural processes that we need. Vitamins A, C, and E are natural antioxidants. So if you see a food being targeted and being said it's high in antioxidants, what they really mean is generally it's got high amounts of vitamins A, C, and E. Okay? Sometimes artificial antioxidants are added to foods. That's to give them a longer shelf life.